I'm going to show you guys a quick demonstration of what I've been working on. Good? Oh, yeah. OK. So I'm going to do a quick demo here. So basically, what I'm going to be showing you is so the Blake2 hash function. And there have been an EIP proposal for adding that as a precompile to Ethereum. But I'm going to show you that as a WebAssembly contract. OK, so let's dive in here. Oops. Okay. Yeah. So, all right. So, all right. So the first thing here that we have is I have a modified C++ Ethereum client running, and there's nothing. Perfect. Okay, great. Okay, so let's pull up. So I have this contract written in Rust. I'll just do a quick overview of it. So I found this Rust Blake2 library. Basically, what it does is it just hashes the value 0 and stores the result to storage. So yeah, so this is the Rust code. I guess like one thing to note here is so how in eWASM how we interact with Ethereum is we import methods from the Ethereum interface. So like if you can see on line 16, storage store. Yeah. Okay. So. Oh, is it? Yeah, that's pretty bad, isn't it? Okay. Yeah. Is that good? A little bit more. Yeah, that's okay. So yeah. So basically, like I was saying, on line 16, we include storage store to interact with. To put the result of this hash on the blockchain. And then I'm going to scroll down. So yeah, it's pretty, I mean, I don't really want to explain the details of the code, but all it does is hash the value 0 and store it as storage to location 0, right? So I am going to execute a little script, which is going to build that Rust into WebAssembly. Okay. So, and then, let's see, I need to execute a second script. And what this is going to do is, so in order to deploy a contract, you have to pass it as data to a transaction, and the code in that data has to return the code for the contract. So this is just going to create the data that will allow us to do that. And then let's actually send the transaction that will create the contract. Okay, so let's see. Let's see what the transaction receipt is going to tell us. Okay, it hasn't been included in the blockchain yet because a block still needs to be mined. So let's wait for this to tick to 10. It's mining pretty slow right now. Okay. Yeah, okay. Great. All right, so that's not really, it's not easy to read, but basically this is telling us that it created a contract at this address. So let's actually invoke that contract. Okay. So I'm just going to scroll up to make sure that that was executed. Oh, I set the nonce too low. Let's do that again. Okay. And then I'm gonna grab the receipt from that just to, oh yeah, it still needs to mine a block for that to actually be included. Okay. It's mining slow today. Great. Okay. Yeah. And so Casey created a nice little UI so that I don't have to keep showing you the command line. So let's actually view the contract that was created through this eWASM Explorer UI. And let's wait for the page, just needs to refresh here. Oh, yeah. Yeah, I did. Sorry, my computer's. Yeah. Good. Okay. So it needs to actually load up the accounts here, and it will star the WASM contract with a little tag once it's loaded. Or maybe not. Maybe I just need to open it up. No, it's still loading. Oh. Let's try refreshing it. Okay. So yeah, it's oh, not connected. Third time was the charm. And hopefully it will load the account now. Yeah, okay, this is not working as I had intended it to. Of course, it always works when I use it on my own machine, but as soon as I come up to demo it, yeah, so basically what this should show you, and you're just gonna have to take my word that it works, is it should show you that so if we scroll back to the contract here, So what you should see on that block explorer is if you see line 36, those are the 4 bytes that we should be receiving as the first bytes of the hash. And yeah, those are stored on the blockchain. Yeah, that's my demo. Thanks.